Across arid desert regions, where water is scarce and the soil is heavily affected by salinity, China has transformed land once considered almost impossible to cultivate into productive aquaculture farms. Each year, the country produces more than 60.6 million tons of farmed aquatic products, with an estimated 10,000 to 20,000 tons coming from desert aquaculture systems. From Xinjiang to Gansu and Ningxia, groundwater, snowmelt, and even saline alkaline water, once regarded as useless, are now being converted into valuable resources for fish and seafood production, generating tens of millions of yuan for some local projects. So how can fish survive in the middle of the desert, and what technologies has China used to create seafood without the sea? Join Terran Works as we explore the answer. China has a vast arid belt stretching from Xinjiang through Gansu and Ningxia to Inner Mongolia, encompassing major deserts such as the Taklamakan, Gurban-Tungut, Tengger, and Badayin-Jaran. The Taklamakan alone covers approximately 337,600 square kilometers, making it the largest desert in China. Despite the harsh conditions, the edges of these deserts still contain groundwater, rivers, snowmelt, and large areas of saline alkaline land that are no longer suitable for growing crops. Rather than allowing these resources to go to waste, China has developed aquaculture ponds and tanks to create new livelihoods for farmers, supply food to regions far from the coast, and transform degraded land into an economic asset. Depending on the location, water is channeled into oasis ponds. Its mineral composition is adjusted to create conditions similar to seawater, or it is used directly in reservoirs and high-altitude lakes. There was no single starting year for desert aquaculture across China. However, a clearly documented modern milestone came in 2016 when Jingtai County in Gansu began using aquaculture to rehabilitate saline alkaline land along the edge of the Tengger Desert. The model later expanded and gained wider attention in Xinjiang during the 2020s. The desert seafood model begins with a resource that was once considered almost worthless: saline alkaline groundwater beneath arid land. This water cannot be used directly for drinking or crop irrigation, but when properly treated, it can become a suitable habitat for marine fish, shrimp, and crabs. The first step is to collect water samples and measure salinity, alkalinity, pH levels, and mineral composition. Unlike natural seawater, inland saline water often lacks certain essential elements or contains them in unbalanced proportions. Technicians must therefore add potassium, calcium, and magnesium while adjusting the salt concentration to meet the specific requirements of each species. Once the water reaches the required standard, it is transferred into membrane-lined ponds, concrete tanks, or greenhouse farming systems. The waterproof lining helps retain water in the hot, dry climate while preventing salt from spreading into the surrounding soil. Juvenile fish and shellfish are not released immediately. They first undergo an acclimatization process in which salinity and temperature are adjusted gradually. Once the stock has adapted, automated systems maintain the necessary conditions while wastewater is treated and reused. By effectively recreating seawater, these farms can raise grouper, mullet, white-leg shrimp, and crabs deep inland, thousands of kilometers from the nearest coastline. Juvenile fish are transported from southern China to the farming areas, where they undergo a gradual acclimatization process to avoid shock from inland water whose mineral composition differs from that of seawater. Because grouper thrive in warm and stable environments, they are commonly raised in concrete tanks inside greenhouses. Farmers closely monitor feeding behavior, growth rates, and the overall condition of the stock so they can adjust feed portions or stocking density when necessary. Slower-growing fish are separated to prevent them from competing with larger individuals. Once the fish reach a weight of around 500 to 600 grams, they are harvested, graded, and delivered to local markets, restaurants, and supermarkets. Grouper command a much higher price than many common freshwater species, allowing farms to generate substantial income from land that was previously difficult to cultivate. With its firm white flesh and relatively few small bones, pearl grouper is commonly steamed, grilled, fried, cooked in hot pots, or braised in sauce. In addition to being sold whole and live, the fish can also be processed into fresh fillets, frozen products, portioned cuts, or ready-to-cook items for restaurants and supermarkets. The head and bones can be used to make stock, while the skin and other processing byproducts may be converted into fish meal, animal feed, or used to extract gelatin and collagen. This helps increase the value of nearly every part of the fish. Not every aquaculture farm in China's arid regions relies on saline alkaline water. Around oases and settlements along the desert margins, farmers also use river water, irrigation canals, groundwater, and snowmelt from nearby mountains to raise freshwater fish. The water is transported to ponds through canals or pipelines. Depending on the terrain, farmers may use renovated earthen ponds, concrete ponds, or ponds lined with waterproof membranes. This design is especially important on sandy ground, where water can quickly seep away if it is not properly contained. Rather than being used for only one purpose, the water often moves through an integrated cycle. It first passes through the fish farming area. The nutrient-rich water is then redirected to irrigate crops, while sludge collected from the pond bottom is used as organic fertilizer. As a result, the same volume of water can produce both aquatic products and crops. Oasis ponds commonly raise carp, grass carp, silver carp, crucian carp, tilapia, and snakehead fish. Many farms use polyculture because each species feeds at a different level of the water column. This arrangement makes better use of natural food sources and helps reduce excess organic matter in the pond. The model does not turn the desert into an ocean, but it allows small water sources in arid regions to become far more productive farming systems. Carp are among the species best suited to freshwater ponds around desert oases. They are highly resilient, can tolerate moderate fluctuations in temperature and water quality, and do not require overly complex farming conditions. This is a major advantage in regions where summers are hot, winters are cold, and water must always be used carefully. Carp can be raised on their own, but they are more commonly farmed alongside grass carp, silver carp, and crucian carp. While carp search for food near the bottom, silver carp feed on plankton, and grass carp consume aquatic vegetation. Each species occupies a different feeding zone, helping the pond ecosystem remain more balanced. Before harvesting, feed is gradually reduced to clear the fish's digestive systems and limit waste. Farmers then lower the water level, use nets to gather the fish into one area and sort them by size. Market-ready fish are transferred to clean water tanks, while smaller individuals continue growing for the next harvest. Some larger facilities also use fish pumps or specialized lifting equipment, shortening the harvesting process and reducing injuries during handling and transportation. White-leg shrimp are among the most prominent species raised in Xinjiang's desert seafood systems. The larvae are initially reared inside greenhouses and then gradually acclimatized to inland saline alkaline water. Before stocking, farmers adjust the salinity, temperature, and mineral composition. Throughout the farming cycle, oxygen levels, feed supply, and stocking density are carefully controlled. Once the shrimp reach market size, feeding is reduced, sampling nets are used to check their condition, and part of the water is drained to concentrate them in the harvesting area. The shrimp are quickly collected, washed, graded by size, and placed in chilled water or ice to preserve freshness before transportation. White-leg shrimp can be steamed, grilled, salt-roasted, deep-fried, or served in hot pots. On an industrial scale, they are also processed into frozen shrimp, peeled shrimp, packaged cooked shrimp, and dried shrimp. The shells are not discarded, but can be processed to extract chitin and chitosan, valuable materials used in food products, cosmetics, and biomedical applications. Rainbow trout are one of the most representative species raised in Xinjiang's cold water farming systems. Although outdoor temperatures can exceed 40 degrees Celsius in summer, the fish continue to thrive in tanks supplied with water from underground springs, mountain rivers, or melting snow. The juvenile fish are initially kept in smaller tanks so they can adapt to the farm's water conditions and feeding regime. As they grow, samples are weighed, the fish are graded by size, and then transferred to larger farming areas. Separating them by size helps maintain more even growth and prevents larger individuals from consuming most of the feed. Rainbow trout are strong swimmers and require a protein-rich diet. Farmers closely observe how the fish respond during feeding. A sluggish movement or a loss of appetite may be the first sign of a health problem. After about 1 year, the fish can reach market size. They are harvested with nets, graded, rapidly chilled, and transported to restaurants or supermarkets. Their pinkish-orange flesh and high commercial value have made rainbow trout a standout product in Xinjiang's cold-water aquaculture industry. The presence of this species creates a remarkable paradox. A fish normally associated with cold rivers is being produced in one of the hottest and driest regions of China. In addition to artificial ponds and recirculating systems, Xinjiang has also developed aquaculture in reservoirs, rivers, and high-altitude lakes. In areas with large bodies of water, floating cages allow farmers to use the natural environment directly without digging ponds or constructing an entire tank system. Before cages are installed, the site must be carefully assessed for water depth, wind direction, current speed, temperature, and water circulation. Sheltered areas may allow organic matter to accumulate, while locations exposed to strong waves can threaten the stability of the floating structures. Each cage consists of floats, a supporting frame, submerged netting, and anchor lines secured to the lakebed. Juvenile fish are stocked at a density suited to the cage volume and the lake's natural capacity to disperse waste. Farmers may also use underwater cameras to monitor the fish, inspect the nets, and adjust feeding levels. In warm water reservoirs, carp, grass carp, and silver carp are common choices. High-altitude lakes, by contrast, have colder water and higher oxygen levels, making them more suitable for cold water species. The main advantage of this method is that it makes use of existing water surfaces while reducing construction costs. However, production must remain within the lake's ecological carrying capacity. If stocking densities are too high, uneaten feed and fish waste can damage water quality and disrupt the natural ecosystem. For this reason, cage farming and fish stocking in lakes should be regarded as part of Xinjiang's broader arid region aquaculture industry, rather than automatically being described as fish farming in the desert. One of the most distinctive species found in Xinjiang's cold water lakes is the northern whitefish, often described as the queen of cold water fish. In 1998, fish eggs were brought from Russia to Saline Lake, where they were incubated at a hatchery before the juveniles were released into the natural waters. Unlike fish raised at high densities in tanks or cages, northern whitefish are cultivated through a system that closely resembles natural ranching. Once released, they can move across a wide area, search for natural food, and grow in the lake's deep, cold, and clean waters. Human involvement is mainly focused on hatchery production, determining the number of fish to be released, and managing the harvesting season. Fishing is restricted to specific periods and catch limits, ensuring that the population has enough time to recover. During the harvesting season, the fish are caught with nets and quickly transported to shore for grading, cleaning, and cold storage. Thanks to the quality of their flesh and their unique habitat, they have become one of the signature products of Xinjiang's cold water aquaculture industry. This stocking model has transformed Saline Lake from a body of water with limited fish resources into a valuable aquaculture production area. However, its long-term success still depends on strict control of stocking levels and harvesting intensity. When people think of Turkey, they often picture the hot air balloons drifting across the skies of Cappadocia, the rocky valleys that resemble the surface of another planet, or the iconic blue Nazar charm that appears everywhere, from homes and shops to souvenir stalls. Yet behind these distinctive images lies a less noticed reality. Turkey did not build its agricultural sector on ideal farmland. Arable land accounts for only a little over 1/4 of the country's territory. Behind its famous farming regions is a harsh reality. Large areas are too steep, too dry, covered with thin, rocky soils, highly vulnerable to erosion, and short of water for easy cultivation. Deep in the interior, long summers, irregular rainfall, and poor water retention make irrigation not just important, but essential for survival. In Konya, one of the key agricultural regions of central Anatolia, excessive groundwater extraction and prolonged drought have even created massive sinkholes in the middle of farmland, serving as a stark warning that the land here is not only dry, but is also being drained from below. Yet despite these limitations, Turkey has built an agricultural sector worth around $68 billion. This achievement is not the result of perfect natural conditions, but of choosing the right crops for the right regions, expanding irrigation infrastructure, and managing every drop of water more efficiently. One of the ways Turkey deals with drought is by turning water into a technology-controlled system. In the southeast of the country, the Giat Peat project is seen as the biggest symbol of this ambition. The project includes 22 dams, 19 hydroelectric power plants, and irrigation systems for around 1.8 million hectares of land in the Euphrates and Tigris river basins. The idea behind it is clear: bring water to hot, dry regions to grow cotton, wheat, corn, fruit trees, and vegetables. But the modern side of irrigation is not only found in giant dams. Turkey is gradually shifting from traditional flood irrigation to closed pipe systems, sprinkler irrigation, and drip irrigation. With closed pipe systems, water no longer has to flow through long open canals, which helps reduce losses from seepage and evaporation. With drip irrigation, water passes through plastic pipes, filters, pressure-regulating valves, and drip emitters before falling directly into the root zone of the plants. As a result, crops receive water exactly where they need it, instead of the entire field being soaked. In vineyards, orchards, and greenhouses, these systems are also combined with soil moisture sensors, weather stations, automatic pumps, and fertigation units. This means irrigation in Turkey is no longer just about bringing water into the field. It has become a precision management network, measuring the soil, tracking the weather, controlling pumps, filtering water, distributing pressure, and delivering every drop to the right plant. If there is one product that gives Turkey a special position in global agriculture, it is the hazelnut. The country usually supplies around 60 to 70% of global hazelnut production, with more than 700,000 hectares under cultivation. In 2024, Turkey's hazelnut exports reached more than 320,000 tons of kernels, generating around $2.6 billion. This means that many chocolate bars, confectionery products, ice creams, and praline fillings around the world may begin on the hillsides along the Black Sea. The heart of the hazelnut industry lies in provinces such as Ordu, Giresun, and Düzce. Many hazelnut orchards here are not located on flat fields, but stretch along steep mountain slopes, where the climate is humid, cool, and rainy. When harvest season arrives, in steep orchards, people still have to pick the nuts or collect fallen hazelnuts by hand because large machines are difficult to operate. But in gentler areas, some stages have been mechanized. Mowers clear the ground before harvest. Leaf blowers gather the nuts into rows. Vacuum machines or harvesters collect the nuts from the ground. Then, threshing machines help separate the nuts from leaves and the green outer husks. After harvest, the hazelnuts are sun-dried or placed in temperature-controlled dryers to reduce moisture, limit mold growth, and preserve kernel quality. Once dry enough, they are sent to factories for cleaning, sizing, cracking, and kernel extraction. Sieving machines, air blowers, and optical sorters continue removing empty nuts, broken kernels, dark kernels, and impurities. Finally, the kernels can be sold raw, roasted, chopped, ground into flour, pressed for oil, or processed into paste for the chocolate industry. Turkey is one of the world's largest honey-producing countries. In 2023, it produced around 114,000 tons of honey, thanks to its highly diverse ecosystems: pine forests in the Aegean region, wildflowers across the Anatolian Plateau, chestnut forests along the Black Sea, and mountain valleys in the east. What makes Turkish beekeeping especially interesting is that many beekeepers do not keep their hives fixed in one place. Instead, they practice migratory beekeeping. When the flowering season begins in one region, the hives are loaded onto trucks and transported there. When the nectar source declines, they move to another area. As a result, bees can collect nectar from many different sources, producing wildflower honey, chestnut honey, pine honey, meadow honey, or honey from fruit orchards. The production process begins with inspecting the colonies, adding frames, and monitoring the health of the queen bee. When the honeycombs are full and sealed with wax by the bees, the beekeeper removes the frames from the hive. In modern facilities, they use electric or heated uncapping knives to remove the wax caps, then place the frames into a centrifugal extractor. This machine spins rapidly, forcing the honey out of the comb while keeping the wax frame intact, allowing the bees to reuse it. After that, the honey is filtered through mesh screens to remove wax particles, then transferred into stainless steel settling tanks. Finally, it is filled by machine into glass jars or large containers, labeled according to floral source, and sent to the market. What makes Turkish honey unique is that each region creates a different flavor. But the industry is also highly sensitive to climate. If drought lasts too long, plants produce fewer flowers and bees collect less nectar. So beekeeping in Turkey is not just about producing honey. It is also a constant journey following the flowering seasons across the country's map. One of the most distinctive images of Turkish agriculture is the Angora goat. This breed is closely associated with the Ankara region and is famous for its long, curly, and silky fleece. From this fleece, people produce mohair, a lightweight, lustrous, and durable natural fiber, often used in sweaters, scarves, high-end textiles, and handmade products. Mohair was once a major source of pride for Turkey, but the industry has shrunk significantly compared with its golden age. In 1991, the country had more than 1.18 million Angora goats and produced around 1,379 tons of raw mohair. By 2024, the Angora goat population had fallen to around 202,000 head, with mohair production at about 339 tons. Even so, Turkey remains one of the important countries in the global mohair industry. What makes Angora goats special is their ability to adapt well to dry plateaus, mountainous areas, and nutrient-poor grasslands in central Anatolia. In places where crop farming is difficult because of water shortages or poor soil, goat raising becomes a way to make use of the landscape. Farmers usually graze the goats on pastures, provide extra feed in winter, monitor newborn kids, control parasites, and protect the herd after shearing, because the goats are more vulnerable to cold at that stage. The process of making mohair begins with regular shearing. After shearing, the fleece is gathered and sorted by length, fineness, color, and cleanliness. Fiber from young goats is usually softer and finer, so it has higher value. The raw mohair is then pressed into bales and transported to factories. There, the fleece is washed to remove dust, grease, and impurities. Next come carding, combing, spinning into yarn, and then dyeing, weaving, or knitting into sweaters, scarves, fabrics, and fashion products. In this way, the Angora goat reveals a very different side of Turkish agriculture. It does not only produce food, but also creates valuable materials and high-end fashion products. When people think of Turkey, many think of Turkish coffee. But in everyday life, tea is actually the more popular drink. From restaurants, offices, and bus stations to family living rooms, small tulip-shaped glasses of tea appear almost everywhere. The center of Turkey's tea industry lies in Rize and the eastern Black Sea region. This area has conditions that are very different from much of the country's interior. The sea on one side, mountains on the other, high humidity, abundant rainfall, and green hillsides all year round. Thanks to this climate, Rize has become the most important tea-growing region in the country. In 2023, Turkey produced around 343,500 tons of processed tea, almost fully meeting domestic demand. Average tea consumption reached about 4.6 kilograms per person per year, while exports accounted for only a small share, at just over 5,000 tons. Tea plants in Rize are usually grown in dense rows along the hillsides. Farmers have to prune them regularly to keep the bushes low, stimulate young shoots, and make harvesting easier. Because of the steep terrain, many areas still rely on hand-picking or handheld tea-cutting machines with collection bags attached behind them. These machines help quickly cut the buds and young leaves from the surface of the tea canopy. After harvest, the tea leaves are quickly transported to factories for processing. The process usually includes withering, machine rolling to break down the leaf structure, oxidation to create the color and flavor of black tea, then drying and grading. Finally, the tea is packaged as loose-leaf tea, tea bags, or higher-end product lines. In western Turkey, the Aegean region is the center of one of the country's most traditional export products, sultana raisins. These grapes are mainly grown in Manisa, Izmir, and Denizli, where the summers are hot, sunny, and dry, ideal conditions for natural drying. In the 2023-24 season, Turkey produced around 245,000 tons of sultana raisins. By the 2024-25 season, although exports reached only about 153,000 tons, revenues still exceeded $546 million thanks to a sharp rise in prices. Even in the vineyard, growers have to control the variety, planting density, pruning, irrigation, and harvest timing. Grapes used for raisins are usually seedless varieties with high sugar content. When the bunches reach the right level of ripeness, workers cut them by hand to avoid bruising the fruit, then transfer them to the processing area. Before drying, in many places the grapes are dipped in a solution of potassium carbonate and olive oil. This coating thins the natural wax layer on the grape skin, allowing moisture to escape faster, shortening the drying time, and helping preserve a more attractive golden brown color. Once the grapes are dry, they are taken to factories for cleaning, stem removal, washing, size grading, and additional drying if needed. Modern processing lines also use color sorters, laser scanners, X-ray sorters, and metal detectors to identify damaged fruit, small stones, impurities, or foreign objects. Finally, the raisins are packed in bulk cartons or retail packaging, then exported to Europe, the United Kingdom, the Middle East, and many other markets. If hazelnuts are the brown gold of the Black Sea, then dried apricots can be seen as the treasure of Malatya. This is Turkey's most important apricot-producing region, usually accounting for around 80 to 85% of the country's dried apricot output and having a major influence on the global market. In 2024, Turkey's apricot exports reached around $475 million, with dried apricots accounting for about $400 million. What makes Malatya special is its climate. Hot, dry summers help apricots accumulate sugar, while the difference between daytime and nighttime temperatures gives the fruit a richer flavor. When the apricots ripen, farmers usually harvest them by hand or shake the branches so the fruit falls onto tarps, reducing bruising. The fruit is then sorted by size and ripeness. For bright yellow-orange dried apricots, the fruit is often treated with sulfur dioxide to preserve its color and extend shelf life. Naturally dried apricots, on the other hand, have a darker brown color and a deeper flavor. After treatment, the apricots are dried on trays, tarps, or drying yards under the sun. Once the fruit begins to shrink, workers remove the pits, press the apricots lightly into a flatter shape, and then continue drying them or move them into drying systems. At the factory, the dried apricots are washed, re-dried, size graded, and inspected using sieving machines, optical sorters, and metal detectors before being packaged for export.